Hi, in this lecture we are going to talk about the concrete implementation of the queue abstract data type. Unlike stack, it has a FIFO structure, so first in, first out. So we have the FIFO structure, which means that the first item we insert is going to be the first item we take out. Okay, so let's implement the class queue. Okay, and of course we will have several methods such as the enqueue and the dequeue method. So first of all we have the constructor with the self, and we just have to create a one-dimensional array. So self.queue is equals to a one-dimensional array. At the beginning, of course, it is empty. We can define the isEmpty method, which is going to check whether that given queue is empty or not. So it's going to check whether this queue is equals to an empty queue or not. Okay. As you may guess, it's going to return true if it is equals to an empty array, which means that the given queue is empty. Otherwise, it returns false, which means that there are items inserted into the queue abstract data type. And again, as you can see, we are able to use a one-dimensional array as the underlying data structure for the queue abstract data type. It's very similar to what we have seen for stack. Stack is an abstract data type. Queue is an abstract data type, but we have an underlying data structure, the one-dimensional array. Okay, we have the enqueue. It's going to get data, and we just have to insert it into the queue. So let's append it, this given data, to the one-dimensional array. What about dequeuing? We just have to get the data. It's going to be the self.queue 0 instead of -1, what we have seen for the stack. This is how we get the last item. But here, queue has a FIFO structure, so the first item we insert is going the first item we take out. So we have to define the index of the first item, which is 0. Then we have to get rid of the reference, self.queue with 0 index, and then we have to return the data itself. Okay, again we have a peek method which is not going to remove the item, but it's going to return the value. So we are just going to return the self.queue with the 0 index. And of course we have the size of the queue, which is going to be the return length of the self.queue one-dimensional array. Okay, something like this. So this is the queue abstract data type. We keep inserting items 10, then 4, then 20. Okay, and the dequeue operation is going to take the first item we have inserted, which is the 10. Okay, then we take out the 4 when we call dequeue again. So this is how queue abstract data type works. Let's try to test it. I'm going to create a queue as a new queue, and I would like to enqueue several items. 10, for example. I'm going to copy and paste, for example, 20, then 30. Then I would like to print out the size, which is going to be the queue dot size of the queue. Okay, something like this. Then I would like to print out the queue, and we just have to append the queue dot the queue. Okay, I'm going to call this method once more, and then I would like to print out the size again. So let's copy and paste it. Okay, what are we expecting? We keep enqueuing 10, 20 and 30, so the size is going to be 3. There are 3 items in the queue abstract data type. Then we are going to dequeue the first item we have inserted, so we get 10. Then we dequeue the second item we have inserted, which is 20. And then we get the size. The size is going to be 1 because we have already get rid of 2 items. So let's see whether it's working fine or not. I would like to run the Python queue.py. Okay, the size is 3 at the beginning because we have inserted 3 items. Then we get the first item we have inserted, the second item we have inserted, and because we have managed to take out 2 items out of 3, the size is going to be 1. There is a single item in the abstract data type after the queue operations. So this is how queue abstract data type works. It has a FIFO structure, so the first item we insert is going to be the first item we take out. Why is it good? Because lots of advanced algorithms relies heavily on the queue abstract data type. For example, the breadth-first search. If we want to traverse a huge graph, we can make it with the help of breadth-first search, and breadth-first search relies heavily on the queue abstract data type. Or for example, we can make a priority queue. It is a modified version of the queue, and it's going to be very important when we are dealing with shortest path algorithms, for example with Dijkstra's algorithm. So this is why this queue and stack abstract data types are quite important as far as algorithms and data structures are concerned. Thanks for watching.